In section 4, we're going to look at trigonometry. So specifically in this lesson, we're going to look at finding trig ratios using right triangles, and we will use those trig ratios to find angle measures in right triangles. There's a lot of background information that I'm going to have to give you before we can just jump right into this lesson. So the first thing that you're going to want to do is take out your calculator. And on your calculators, you should see buttons that look like this: sine, cosine, and tangent. We will use the inverse buttons eventually, but for right now, you don't need to worry about those. I'm just focused on these three: sine, cosine, and tangent. And in order for this to work, we need to make sure that our calculators are in the correct mode. So what I want you to do on your calculator is to type in sine of 20, and you should come up with a decimal answer. I will do the same on my calculator, and if you don't get the same value, then we need to change the mode on your calculator. So I'm going to start with my sine button on my calculator is right here. I know a lot of you will have different calculators, and that's okay. But these are the ones that I seem to have the most issues with, making sure that they're in the right mode. Otherwise, you can Google how to do this as well. But if you have a TI-84 plus or 83, the same ideas will work. So I'm going to type sine of 20 in my calculator, and you should come up with approximately this decimal. If you don't get this, then we need to change the mode on your calculator. So for this particular calculator, to change the mode, we're going to go to the mode button, which is right next to second. You're going to click on it, and it's the third one down. If yours is highlighted as radian, you need to highlight it to degree instead. So what you'll want to do is scroll down, scroll over, and hit enter. So that way you get degree highlighted. Mine was already highlighted, so it's not going to change mine at all, but it will change yours. Once you get it changed to degree mode, then you can press second, quit, and then I want you to type it in again, sine of 20, and you should get the correct decimal at that point. Okay, again, if you didn't get that, you'll probably want to stop this video and Google how to change your calculator to the correct mode as well. Once you have your calculators in the correct mode, now we're going to start talking about what is trigonometry. And these three buttons on your calculator represent ratios of side lengths. So first off, trigonometry we're saying is the study of triangle measurements. That could be side lengths, that could be angle measures. We're specifically going to focus in right triangles. So within your notes, you're going to want to write down what does sine, cosine, and tangent mean. And on your paper, you're going to want to say sine of some angle measure. Don't necessarily worry about that as much. Is just opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So looking at this triangle off to the right, we can use either acute angle measure. It always is going to go off of the acute angle. So it could be either angle A or angle B, but it will never be the right angle. Okay, we're never going to deal with that. So in this case, if I'm focused on angle A, we have what is called an opposite side, an adjacent side, and the hypotenuse of a right triangle. The hypotenuse, I'll start there, we know is always the longest side length across from the right angle. So C in this case is going to be considered the hypotenuse. The opposite side, opposite means farthest away. So this side length down here would be considered opposite. And adjacent means the side length right next to, but not the hypotenuse. Okay, if I was going to focus on angle B instead, that would change it a little bit, not a lot. If I focused on this angle measure, the hypotenuse stays the same, but now the opposite side length would be over here, and the adjacent would be down here in relationship to angle B. Okay. I do want to show you that these ratios, we're dealing with similar right triangles. We dealt with specific ones in the last lesson, but now we're focused on all right triangles that have certain angle measures. So just to kind of help you understand what do these functions actually mean, we know that they mean a ratio, like opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, but I want you to specifically see it. So right now I have one right triangle. This right triangle has an angle measure of 49 degrees, and I have some side lengths in here as well. So I'm just going to focus on sine, but you could do this with cosine, you could do this with tangent as well. So if I typed in sine of 49, that would get me an actual decimal answer. So why don't you do that? I'll do it on mine as well. If I type in sine of my angle measure of 49 degrees, I'm going to get a decimal value off of this. Okay. We also know that sine means the opposite side length over the hypotenuse. So the opposite side length to 49 would be this one over 6.6. That's your hypotenuse. And if I do that, look at that, it comes out to approximately 0.75, which, if I pull up my calculator, look at that, it's pretty close. Now, the even cooler part is if I give you another triangle, here's another one. These two triangles are similar. This original blue one and now this red one, these are similar triangles. We could prove that by angle. One angle measure of 49 and another angle measure of 90 degrees. These have to be similar triangles by angle. If I do the same thing, I'm going to get rid of this one, that blue one for a second. If I focus on sine again, within this red triangle now, opposite over hypotenuse, I should get the same decimal answer, and I do. Okay, so that's the idea that we're dealing with. If I take sine of 49 degrees, that should be equal to the ratio of the opposite side over the hypotenuse. Okay, keep that in mind. You do the exact same thing with cosine and the exact same thing with tangent, and you should come up with the same decimal values when you find those ratios. Okay, so that's what we're going to be working on in this section.